Hello, my friends, and welcome back. We are at Microsoft Ignite, and I'm super excited to be here with Ganesh from NVIDIA and Don from Synopsys. Why don't we just dive right in? What are the problems that we're trying to solve? I hear you brought something for us to see.
Yeah, so hello everybody, this is Ganesh Sivaraman. So what you're seeing here is a bottle filling simulation that Synopsys has built here. We're going to dive into the depths of it, how it was done, why it matters, and how you can get started. And all of this, what you're seeing here is using Ansys Fluent Solver, using Omniverse technology, all running on Azure. So the whole idea here is to actually democratize and make the whole simulation experiences a lot easier and a lot accessible to a broader set of users.
This is cool. So basically, diving right into the problem, NVIDIA and Synopsys together are making manufacturing a little bit easier by being able to do simulations before, because it's probably much more expensive to do it in the actual real life. Is that right?
Yeah, so that's a great point. So the way we think about from an NVIDIA perspective is the world is accelerating towards a lot of GPU accelerated workloads. The way we think about the world is we're moving towards the physical AI. And the way we think about physical AI is applying AI to the real world, the physical world that we are thinking about. The way the whole ChatGPT moment and the Gen AI that happened, that is now actually accelerating to the real world, the physical world that we live in. The way NVIDIA solves that problem is a three-computer problem. We think about actually training these massive AI models, which is what we use through our DGX computer.
Right.
Then we run real-world, physics-based, massive world-scale simulation, which is what we use Omniverse for. Omniverse is designed for simulations and digital twin. And then the last part is bringing all of that to the physical world, which we do through AGX, which is our third computer. And the way we solve this with our partners like Synopsys, today what we're discussing specifically is how to think about physics-based real-world simulations at scale. And the way we think about that is a layered structured infrastructure to a software stack problem. The first thing, of course, it starts with our GPUs, which is the latest generation RTX Pro 6000, which is now available on Azure as well. And then there's a whole set of libraries and technologies, which is the NVIDIA Omniverse libraries that we provide on Azure to help folks like Synopsys to build their simulation workflow. And then on the top, Synopsys actually has built the simulation workflow for bottle filling, which is what we're going to get into more details about it. So all of this essentially is truly possible at world scale, which is physics enabled to really solve massive problems in a much more cost-effective and a timely manner.
That's amazing. So tell us, Don, about what Synopsys brings to all of this, because I'm sure there's a lot of stuff that you've been doing for a long time that really lights this up. Tell us about that.
Synopsys simulates physical systems, computational fluid dynamics, mechanical systems, airflow, electromagnetics. We do an incredible job of simulating in a virtual world what is going to happen in the real systems. And the thing that is great about working with Microsoft and NVIDIA is a couple of things have been gating our ability. It's been the access to compute, and with the accelerated computing that's brought forward by the NVIDIA GPUs, as well as the incredible Azure platform, it's removed the barrier of access to compute to simulate the physical world. And with the libraries and frameworks and tools that are being brought forth both by NVIDIA and by Microsoft, it is now possible to build much simpler applications that are amenable to usable by non-experts that can actually go in and simulate staggeringly complicated things to make informed decisions that were just not possible, even 2 years ago.
And that's amazing to me because, like I was thinking, as I talked to these folks beforehand, and I've been thinking about this, how much more expensive it is to actually build out a thing without knowing it's the right thing. And now that you can simulate it, it makes it all much easier to cost out. Do you have an example of a customer who's doing these kinds of things?
In general, it can be. It's like a once-in-a-lifetime opportunity as a technologist. You can increase productivity of your customers by a factor of 10,000. And you can live your whole career and never be able to do that. Example is the bottle filling application that Ganesh was talking about. If you get spillage in a real system, They've got to stop the line, they've got to clean it.
Yeah.
It can take hours, if not days, to recover from it. And now they can virtually design and optimize the entire fluid flow process based on viscosity, optimize the bottle shape, optimize the controls of the bottling equipment so that they don't get the spillage and don't get the line outages.
And to me, that's the cool thing about that is you have some expertise, but you're sharing that expertise as well. Can you tell us a little bit about how you're sharing that expertise?
Well, these problems can be hard to solve, and the most powerful way to help somebody develop a system is programming by example modification. You give somebody a working example that's complete end-to-end, where it's just rinse and repeat for them. And so together with Microsoft, our partners, and NVIDIA, we're releasing to the public in GitHub the well-architected framework that provides a blueprint, sample code, and libraries that dramatically simplify the complexity of building these workflows that are physics aware, that allow people to optimize the real world infrastructure by making decisions and reasoning in a virtual world.
Tell me more about what the well-architected framework is. For those that may be watching are like, hey, I really want to do this. What does it look like?
Well, it is obviously by definition a framework that explains how to bring together the entire end-to-end life cycle of building a solution that is physics aware, AI aware, cloud aware, from how do you set up and model the problem, how do you actually generate the training data for the AI system, how do you produce the surrogate models that can then do the optimization, and then how do you visualize the results of these simulations so that they can be used and accessed by people that are not deeply in the technical domain. So it really is an end-to-end example and an end-to-end framework for building these complex physics-based solutions that probably increases by a factor of 10 the number of people that are allowed to make physics and AI-informed decisions.
And how does NVIDIA go from the well-architected framework? How do you help out there at the end?
It's a great question. So if you look at this architecture, the personas that we are really targeting is non-simulation experts as well as simulation experts. So where we are helping in collaboration with Microsoft, in addition to actually providing the necessary GPU infrastructure that Don was talking about, we're also helping to unlock and lower the barrier for several different community of users as well as developers to tap into it. So let me just show you a full end-to-end example demo. So what you're seeing here, Don actually touched on this briefly. This entire workflow that you're seeing here is addressing two main personas. One is a product designer. So here's an example that I'm a bottle designer. I'm not a simulation expert. I want to actually see how my design is actually going to operate in the real world when it is attached to a filler, which actually typically runs 50 to 100 different bottles in different conditions. So you can actually go check different types of the bottle materials, the viscosity of the fluid, the speed at which it's supposed to be operating, the size of the bottle, whether it's a 500 ml, is it a 2-liter bottle. So you can play several different scenarios in this virtual world, in the simulated world. And the real power is that now you're actually making it easier for even a non-simulation expert. All of this is just a web application, but under the hood, it is stitching all these different pieces of technologies. Do you want to add how the simulation is actually working on this side of this, the workflow?
Sure. As Ganesh said, this is a complicated problem. Ansys simulation, Ansys solvers under the covers apply computational fluid dynamics to simulate how the liquids are going to flow, how they're going to slosh, right? What the fill rate's going to be, how it's going to interact with the vortices in the structure of the bottles, how the viscosity of different liquids is going to cause it to behave differently. So it is doing deep, deep mathematics at a scale of millions and millions of mesh elements. And this is only possible because of the accelerated computing that's now available. And because we can simulate these virtual environments, things that don't exist, we can generate training data that can then be used to train and build surrogate models for real-time optimization of the processes.
You had me at advanced computational models, Don. Obviously, this is amazing, and the amount that people will be able to say, because I hadn't even considered, if you're bottling syrup versus water, it's going to take a different amount of time. And being able to simulate this is amazing. Any last things to say from you? 5 seconds?
This is all available on GitHub repo. As Don said, you can get started today.
Awesome. Don, 2 seconds.
Nope, we're done.
Look at that. I love this. Is awesome. To learn more about NVIDIA, make sure you follow the link on your screen. Thank you very much.